Okay, students, today we're going to work on the unit circle. This is an expansion onto our 30, 60, 90 degree triangles and 45, 45, 90 degree triangles that we worked on at the end of last semester. Um, but now we're applying it to a circle. The word unit, as you see right here, means one. So all the radii, as we see here, from the center of the circle to any point on the circle are already one. So when we have our triangles drawn for each of these quadrants, we can already set the radius equal to 1. That cannot change when we're dealing with the unit circle. If we're not dealing with the unit circle, it can be different lengths of radii, which we'll be dealing with next class. But this class is all unit circle, so these radii are already set at 1. We recall from earlier on our quadrants, quadrant 1 up here, quadrant 2 over here, quadrant 3 down here, and quadrant 4 here. In talking about our degrees, as we talked about, we go positive degrees in counterclockwise direction. So we start over here and we got 0 up to 90 to 180, 270, and back to 360 for the full circle. And if we want to recall plotting points in the coordinate plane, in quadrant 1, we recall that both the x and y coordinates are positive. In quadrant 2, we go left and up, so it's negative and positive for the x and the y. Quadrant 3, left and down, so both are negative. And quadrant 4, right and down, so we have a positive and negative for the x and the y. All right, so what we're looking to do is find the angle that's going to be given to us and draw a triangle in that particular quadrant. A couple vocab words to deal with here that are new is this side here. It's called the terminal side, as you see right here, which means where it ends, and will always be your hypotenuse. When we talk about the angle measure, we're always starting here at 0 and working our way up. So say this is 40 to 30 degrees. We go from 0 up to 30 and we'd stop. And then we connect that to the center, the origin, and that's our terminal side. Next vocab word is the Greek letter theta, and this always represents the reference angle. The reference angle, by definition, as you see down here, is the angle between the terminal side and the x-axis, never between the terminal side and the y-axis. So you see when we draw, I have all these triangles drawn, the reference angle is always the one closest to the origin. Okay, it's between the terminal side and the x-axis. It's not up here between the terminal side and the y-axis. I'd be wrong. Okay, so you're going to draw one of these 4 triangles every time. I've already got these 4 triangles right here drawn for you, so you know what yours should look something like on every problem. Okay, next thing, in order to calculate what that reference angle is, we have it down here. It says to take your angle measure, whatever they give you, if it's in quadrant 1, between 0 and 90 degrees, and subtract 0 from it. So if they said 60 degrees, that reference angle would be 60 degrees. 60 minus 0 is 60. If we're in quadrant 2, such as 120 degrees, because that's between 90 and 180, so we're at 120, as it tells you in quadrant 2, you do 180 minus the angle measure. So 180 minus 120 is 60 degrees. So that reference angle would be 60 degrees right there. And of course, the other angle would be 30, because we have a 30, 60, 90 then. If we're in quadrant 3, say we take the angle 240, which obviously is between 180 and 270, 240. To find this reference angle, we do the angle measure itself, 240 minus the 180. And so 240 minus 180 is 60 degrees. That puts the other angle over here at 30 degrees. So we have a 30, 60, 90 in this case. Lastly, say we have 315 for our angle measure in quadrant 4, between 270 and 360. To find that one, we do the reference angle, we do 360 minus that 315, which is 45 degrees. So we have a 45, 45, 90 degree triangle in that particular case. Okay, if you notice on all of these measures, the 0, the 180, and the 360 in purple here, they're always along the x-axis. So when I'm finding the reference angle, I'm subtracting an angle from or by an angle on the x-axis. So we're never using 90 or 270 to find a reference angle. It's only the ones on the x-axis that we'll be using. And we're going to go over some examples next here. Next down here, we see we are reminding of our relationships on the 30, 60, 90. Our side lengths are A root 3, and 2A. In our 45, 45, 90, we have A, and A root 2. As we already pointed out up here, the radii are always equal to 1. So that 90 degree side is already set at 1. So in this case, 2A equals 1. So if I solve for A, that's 1/2. So the A over here, 1/2. The 30 degree side is always going to be 1/2. We know the 60 degree side is root 3 times longer than the 30 degree side. So root 3 times 1/2 is square root of 3 over 2. So every time we draw a 30, 60, 90 degree triangle in any one of these four quadrants, we're always going to have these same numbers, 1/2, root 3 over 2, and 1. There will be no other numbers. The only that can change will be the signs based off of what quadrant, whether it's positive or negative, based off the x and y coordinates in that particular quadrant. But these numbers by themselves will be the same. Same with the 45, 45, 90. Since the hypotenuse is already set at 1 in a unit circle, if we set that equal to 1, and solve it by dividing by root 2 and then rationalizing it by multiplying by root 2 over 2, we get a equals root 2 over 2. Okay? If you need help on understanding that and forget about it, you forgot how to do that from first semester, we can work on that individually. All right, so now let's go ahead. Even though you have this written down, I'm not going to explain this until we look at some examples here. So let's go ahead and look at some examples on the next page. All right, so tangent 45 degrees. What quadrant is 45 degrees in? You know that's in quadrant 1. So we're going to draw ourselves an XY coordinate plane and draw a right triangle in quadrant 1. So now we have a right triangle in quadrant 1, and if you recall, to get this reference angle right here, we do 45 minus 0 is 45 degrees. So that means this reference angle right there is 45 degrees, which obviously makes the other one also 45 degrees. So we have a 45, 45, 90 degree triangle, therefore, for this triangle right here. And going back, if you forgot again from your notes, we know it's going to be square root of 2 in the x direction, square root of 2 in the y direction, and we already have the hypotenuse set at 1. So now we can go ahead and write in square root of 2 over 2. Square root of 2 over 2 and square root of 2 over 2 for the y. And we know that the radius never changes, it's always 1. Like I told you, these numbers are always set on any time we're doing a 45, 45, 90 degree triangle, no matter what quadrant it's in. Now, the only thing we have to check to see if we have to change either of these signs. Since any point in quadrant 1 is both a positive and a positive for the x and y, we don't have to change either of these two signs right here. Now, tangent, remember from the word SOHCAHTOA, we'll spell out SOHCAHTOA as a reminder here from last semester as well. Tangent, as we see right here, is opposite over adjacent. Remember, this is the reference angle. We're always referring to this angle right here every time. So the opposite, root 2 over 2, divided by the adjacent. Or adjacent means next to. Adjacent, root 2 over 2. So what is root 2 over 2 divided by root 2 over 2? Should be able to tell me that's 1. Any number divided by itself is 1, except for 0 divided by 0, which is undefined. So there we have the tangent, and that is the toughest type when we have to divide two fractions right here. Okay, find the tangent on any of these is going to be the most difficult one to do. These others, as we'll see here in just a second, cosine and sine, which now I'm going to reference back to. You see the sine is always going to be just the y coordinate. The cosine of theta will just be the x coordinate, but we'll show you how that works out here in this next example. So quadrant or cosine of 120 is in quadrant 2. So we go ahead and draw a quadrant 2. Draw your xy coordinate plane. There's my origin, quadrant 2. Put an angle up there. Draw myself a right triangle. Let's get this a little more straight right there. Draw myself a right triangle in quadrant 2. And I know, going back, we know the radius is already set at 1. That never changes. So the hypotenuse is always 1 in every triangle we draw here. And going back to this first page here, on a 30, 60, 90, we know the 30 degree side is going to be 1/2. The 60 degree side, root 3 over 2, and we already put in the root 1. I mean 1 for the hypotenuse. So how do I get this reference angle again? If you forgot, you got it right here. We're in quadrant 2. We do 180 minus that angle measure. So it's 120 degrees. 180 minus 120 is 60 degrees. So that reference angle right there is 60 degrees, which then makes the other angle 30 degrees. We just got done saying that always opposite 30 degree angle is half the hypotenuse, or 1/2, or if you want to put 0.5, I don't care. You can put 1/2 or 0.5 because they're the same thing. And opposite of the 60-degree side is √3/2. So we have our √3/2. These numbers never change. The only thing that will change now is we have to ask about their signs. So in quadrant 2, we know since this is the origin 0, 0, if we're going to the left, that's the negative direction. So I need to add on a negative sign in front of this 0.5 because we went to the left. And of course, then we went up, and so that stays positive. If you want to put a positive sign, you can, but you don't have to. Okay, that hasn't changed. Now, cosine, as we see up here in SOHCAHTOA, cosine is adjacent over hypotenuse. Well, the adjacent side, remember, this is always my reference angle, the one between the terminal side and the x-axis. The reference angle, or the cosine itself, is adjacent, which means next to, over the hypotenuse, negative 0.5/1. So I have negative 0.5 divided by, let's make it a horizontal fraction bar, over 1. Okay, well, what's any number divided by 1? Itself. So the answer is negative 0.5. Now, if you think about this now, if I'm ever dividing by 1, I'm always going to get the same number as the numerator, right? So therefore, I can really wipe out the hypotenuse when I'm dealing with sine and cosine that deal with hypotenuse. So really, this is saying that the cosine is just the x-coordinate, which is what we had written down right here. The cosine of theta is the x-coordinate. Because we divide by 1 every time in the hypotenuse, it just wipes out that 1. Anything divided by 1 is itself. That same rule applies for sine, which is why the sine is just the y-coordinate. Okay, so let's go. We did a tangent one, a cosine one. Let's practice a sine one, and then we'll practice these last 3. Okay, so sine of 210. What quadrant is 210 in? First, draw myself my coordinate plane. 210 is in quadrant 3 between 180 and 240. So draw yourself a right triangle in quadrant 3. And there's my right triangle. I know my hypotenuse is always 1. That never changes for any triangle I draw in my unit circle. And to get my reference angle right here, remember from quadrant 3, we're doing the angle measure, in this case 210 minus 180. So what is 210 minus 180? 30 degrees. So my reference angle is 30 degrees right there, which then puts the other angle at 60 degrees. So we have a 30, 60, 90 again. As we have said all along, anytime it's a 30, 60, 90 degree triangle, we are using 1/2, √3/2, and 1. These numbers never change. So I just have to make sure I put the 1/2 opposite the 30 degree angle, the √3/2 opposite the 60 degree angle. And I've already written in the 1 for the hypotenuse, which is the terminal side. So opposite 30 degree angle is 1/2 or 0.5. Oops, decimal, 0.5. And then we have √3/2 here. And I'm just going to type it in as √3. Let's over 2. We can now go back. Now that this shows up, I can pick the square root symbol now and put it in there. Okay, so I have √3/2. Now, the last thing I need to check are my signs. If I'm in quadrant 3, I need to remember that I went left, which makes this negative, and I went down, which makes the y-coordinate negative as well. Remember quadrant 3, we wrote down negative, negative. Okay, that's a key a lot of students miss, is they forget to switch the signs when they're in depending on what quadrant they're in. They just want to focus on the square root of 3/2, 0.5, and 1 and ignore the signs for that quadrant. So you got to remember your signs for your quadrant. It's the biggest error that most students make. Now, since we're only looking for the sign, remember, as we said, the sign is going to be the opposite, negative 0.5. Remember, this is my reference angle every time between the terminal side and the x-axis. My y-coordinate, in this case, divided by 1. Anything divided by 1 is itself. So that's why it's really just the y-coordinate, which is why we had down here that the sine of theta equals the y-coordinate. Okay, so what is the y-coordinate in this triangle? Boom, negative 0.5. Okay, and there's my answer for sine of 210. And of course, you could check this on your calculator. If you typed in sine, make sure your calculator, check your mode, make sure your calculator's in degrees, and you hit sine 210, and it will give you negative 0.5 in your calculator. So there's another simple way you could check to make sure you had the right answer, and check to make sure you had the right sign. You didn't forget your negative sign. Okay. All right, let's do the last 3 problems here now. So let's go up here. We'll do 300. We just did a quadrant 3-1. 300 is in quadrant 4. So again, we draw our XY coordinate plane, draw a triangle in quadrant 4, draw my right angle symbol. We're always drawing right triangles here. I know my hypotenuse is always 1. That never changes. Now, remember to find this reference angle. If you forget, look at your notes here. Quadrant 4, we do 360 minus the angle. 360 minus 300 is 60 degrees. So 60 degrees is that reference angle right there, which then makes the other angle 30 degrees. Okay, we remember every time the angle opposite 30 degrees is always 0.5. Remember, these numbers don't change. The only that can possibly change are the signs. Opposite 6 degrees is square root of 3 over 2. Let me go ahead and copy this square root of 3 over 2 right here. And we'll just put it over here now. Oops, dang it. Undo that. Undo. Undo. What happened to the undo here? Undo. Dang it. Okay. Forward. Forward. There we go. Forward. Okay. Now paste. All right. There we go. Square root of 3 over 2. Now, the only thing, again, I need to ask myself is, do either of these signs change? Well, if I'm in quadrant 4, I know the x-coordinate is positive and the y-coordinate is negative, so I must put the negative on here. Okay, and I have it right there. Tangent, remember, is opposite, as we see right here, opposite over adjacent. Remember, this is always my reference angle between the terminal side and the x-axis. So the opposite is negative square root of 3 over 2. So we have negative square root of 3 over 2 divided by, let's go ahead, and I like to write it as a horizontal division instead of a long bar underneath here, divided by 0.5 or 1/2. 1 divided by 2. Okay, now we need to remember in division of fractions that our rule for dividing two fractions is to change the division sign to multiplication and then by the reciprocal. So whenever I ask you what division is, you should be telling me it's multiplication by the reciprocal. So now I'm going ahead and changing that to negative square root of 3 over 2 times 2 over 1. Oops, let me make it horizontal. Okay, and I mean vertical. Now I could either just simply multiply straight across and then reduce, or I could cross cancel, not cross multiply. That's for proportions. Cross cancel. Okay, and now I multiply straight across. There was no cross canceling this way. So that gives me negative square root of 3 over 1, which then is negative square root of 3. So the final answer is negative square root of 3 for the tangent of 300. And if I want to test that, I can put in my calculator and put tangent 300. Of course, that's going to give me the decimal answer. So I would need to then also type in negative square root of 3, and that would give me the same answer, the same decimal answer as the tangent of 300 would on my calculator. And that way you can guarantee you're right. All right, tangent 240. 240 is also in quadrant 3. So we draw ourselves a quadrant 3 triangle again. And draw myself a right angle. I know my hypotenuse is always 1, never changes. To get this reference angle again, remember that it is the angle measure itself, 240 minus this 180. Remember, it's always minus the number that's on the x-axis right there, closest to it there, 180. So 240 minus the 180 is 60 degrees. So that tells me my reference angle is 60 degrees. And therefore my other angle is 90. The two are complementary. These two angles add to 90 degrees. So over 30, 60, 90, always opposite the 30 degree side is 1/2. And opposite the 60 degree side is √3/2. So let me copy this √3/2. Okay, and we have √3/2 put right there. And now all I have to do is check to see if I have to change either of the signs to make sure I have the right signs in quadrant 3. Quadrant 3, we went negative in the x direction, so that must be a negative there. And we went negative in the y direction, so it must be a negative there. And since it's asked for tangent, remember tangent is opposite over adjacent. That's the one we're going to have to divide on. So it's negative √3/2 divided by negative 1/2. Now notice we've already done that right here. Negative √3/2 divided by positive 1/2. So the only thing that's going to be different here is we have a negative over a negative, so we get a positive answer. So it's going to be the same answer as this one, except for positive. So we can go ahead and write in our positive square root of 3. We already have the work right there. And lastly, tangent 270. 270 is right down here on the y-axis. So again, draw yourself a coordinate plane. Okay, and 270 is down here. Here's where my 270 is. So you can put your 270 to remind yourself where that is at. And what I need to remember then, if I was to draw my unit circle, this from here to here is the radius. The radius of any, the radius of all radii on the unit circle have a distance of 1. So that point, when I name that point, remember that's the origin right there, 0, 0. So if I go down 1, that point now is 0, comma, negative 1. Okay, so I have my x and y coordinates right there. Now remember, tangent, again, is opposite over adjacent, or as we see here, tangent is the y coordinate divided by the x coordinate. So if I go y coordinate, negative 1, divided by the x coordinate, 0, what is negative 1 divided by 0? It's not negative 1, as some of you just said. It's not 0, as some of you just said. You cannot divide by 0. Anytime you divide by 0, the answer is undefined. So that's our answer for the tangent of 270. So when you put it in your calculator, tangent of 270, you'll get an error message, or it may say undefined. Often it just says error on the TI-84. All right, so now you've seen 6 examples. And now I want you to go ahead and do the worksheet. And if you have any individual questions, when you're at that station for working on your homework, you can ask others, or I'll come over and answer questions for you. Make sure you made any comments and you've written down all these notes right here. Because if I ask you how to do something, I want to say, let me see your notes. I expect to see all this written down. If you need to add more notes yourself personally to something here, such as division is multiplication by the reciprocal, then you need to add that on yourself for a good note taker if you've forgotten that. And that is the end of this lesson. Where's the pause button now? Where's that pause stop button? Do I have to bring this back up? Okay, there we go.